All right. Good afternoon. Any question before we start? So let's continue on force analysis. Force analysis is a lengthy process, but it's straightforward. So if you follow the steps, you should be good.
Come back here. Especially with that one.
So yesterday we started a force analysis of pure rotation for one link with the center of gravity here, with the distance of RG2. This angle was theta 2. This is point A. The length of link is R2. Theta dot, theta double dot are given. We wanted to do force analysis. And one external force applied to point A. Fpx, Fpy. So if I draw the free body diagram of this, between the ground and this point, which is O2, we are gonna see the force. The force coming from the ground applied to link 2. It has two terms, one in x direction. How do I label the force? F, which is coming from link 1 to link 2 in x direction. Force coming from link 1 to link 2 in y direction. Fpx, Fpy. And this is center of gravity. There are three equations on Newton's law of motion. The summation of the force in x direction is going to be the mass of the rigid body times acceleration of center of gravity in x direction. Summation of the force in y direction is going to be m times acceleration of center of gravity in y direction. And summation of the torque or moment about z-axis, rotating about z-axis, is going to be the mass, moment of inertia with respect to center of gravity, multiplied by angular acceleration. So the equation corresponding to this is F12x plus Fpx equals to ma cgx, F12y plus Fpy equals to ma cg in y direction. And this one, we have torque coming from the motor, the Ts. It's a counterclockwise. I just assume it's counterclockwise, so I put the positive sign for that. Plus this force times this distance is making counterclockwise rotation about center of gravity. F12x times Rg2 sine of theta 2. We talked about them. Minus Fpx R2 minus Rg2 sine of theta 2 plus Fpy Rg2 1, 2, 3. Three equations solved for F12x, F12y, and Ts. Acceleration of center of gravity in x direction is negative Rg omega square cosine of theta 2 minus RG2 alpha sine of theta 2. And acceleration for central gravity in y direction is gonna be sine of theta 2 plus RG2 alpha cosine. In matrix form, the variables are f1 2x, f1 2y, and ts. The coefficient of f1 2x in first equation is 1. There is no f1 2y is 0, and there is no ts. And on the right hand side we are going to see ma cg in x minus, it's not, so I move it to the right side, minus fpx. Second equation 0 1 0 ma cgy minus fpy. Last equation, the coefficient of ts is 1, coefficient of f1 2x is rg2 sine, coefficient of f1 2y is negative rg2 cosine. So I will start with rg2 sine of theta 2 minus rg2 cosine of theta 2, and the coefficient of ts is 1. I center of gravity times alpha equals to I forgot the right side. I center of gravity times alpha plus fpx r2 minus rg2 sine of theta 2 minus fpy So this is the third equation. I wrote the system of equation in a matrix form because it's easier to be solved by MATLAB or your calculator. This is what we derived. Here we have RG2 sine of theta 2 First equation, here we have fpx plus f1 2x equals to this. Second one, the third equation, it says ts or t1 2 is going to be f1 2 y times r1 to x. So r1 to x means this distance. This distance. So if you substitute r1 to x with the corresponding equation, you will end up with this equation. So this is for one link which has the pure rotation. We started working on one example. At theta 2 equals to 30 degree, if omega 2 is positive 20, and alpha 2 is 15 radian per second square, if this link is 10 inch and RG2 is 5 inch, means center of gravity is located at the middle of the link, and the mass moment of inertia is 0.08, and weight is 40 pounds. The external force, 40 pounds, Fpy is 0. We would like to do the force at joint. Find the force at the joint and the torque needed to drive the link. So basically we should solve this system equation by finding the terms of this matrix and find these three unknowns. So to do that, I will start from a constant part. M, I should calculate the mass in blob. A, center of gravity, should be calculated. So negative 10 times omega is 20, theta 2 is 30. If you plug in the numbers here, you will get negative 1769. For center of gravity, acceleration of points of center of gravity in y direction, you will find negative 935 inch per second square. It's acceleration of the point, so the unit should be inch per second square. If it's angular acceleration, it's going to be radian per second square. I need to find the mass. Mass is the weight dividing by 386, which is 4 pounds. Our weight is 4 pounds, not 40. 4 pounds divided by 386 is like 0.0104 log. RG2 sine of theta 2 is going to be, RG2 is 5 times sine of 30 degree, which is 0.5, it's going to be 2.5. RG2 cosine of theta 2 is going to be 5 cosine of 30, it's 4.2. So this term is going to be 2.5, this guy is going to be negative 4.3, 1,0,0,0,1,0, 2.5, negative 4.3, and 1 times F1 2x, F1 2y, and Ts. Right hand side mass is 0.014 times acceleration in x direction, negative 1769, negative Fpx. Fpx is 40 pounds, negative 40. Second one is going to be 0.0104 times negative 935 minus 0. I is 0.08, alpha is positive 15, we don't have any FPY, so this term is gone. FPX is 40, R2 is 10, RG2 is 5, 10 minus 5, 5, sine of 10. So I'm just plugging 40 times 5 times sine of 10. So this matrix is given, the value for this is, if I calculate negative 57.67, this guy is gonna be negative 9.39, and last one is 101.2. So if you solve this, you will find f1 to x equals to negative 57.67, f1 to y equals to negative 58.4, and ts would be f1 to y is negative 9. And TS would be 204.7 pound times inch. And these are pounds. So make sure that you know the steps, because the next homework you need to write a code to do force analysis for a 4-bar mechanism. It's just for one link. The next step is we extend this to the 4-bar mechanism. We are gonna rewrite these 3 equations for 3 links. So we are gonna get 9 equations. So this 3 by 3 is gonna change to 9 by 9. Any question about this? Next step that I'm gonna do, I'm gonna extend this to the 4-bar mechanism. I just wanted to show you the steps for one pure rotation, one link which has pure rotation. Now if I connect to link 3 and link 4, you have a 4-bar mechanism. I can rewrite these equations for 3 moving links, get 9 equations, 9 by 9, 9 variables, and 9 by 1 vector. So a single link in pure rotation is one thing, but this simplest mechanism that we have, it's gonna be a 4-bar mechanism. So we are gonna have 4 rigid body. So we are gonna repeat the system, these 3 equations 3 times, because one is ground, it's not moving, we don't have any motion, so no acceleration for center of gravity of the ground, no rotation for the ground, so we are gonna have only three set of equation for three moving links. So this is the general form of four-bar mechanism. One is ground, this is link 2, link 3, link 4. You can have some external force applied to link 3, link 2, or link 4. I just have external force applied to this point. So this is a general form of four-bar mechanism. The center of gravity of each link should be given as a noun. The four-bar mechanism that I'm gonna work on, that I assume that we have only rigid bar with the center of gravity located at the middle. Just to simplify the calculation, I'm not gonna lose the generality of the problem, but I assume that center of gravity for link 2 is right here, center of gravity for link 3 is right there, and center of gravity for link 4 is at the middle of link 4. This is R2, R3, and R4. Theta 2, theta 3, theta 4. So let's see what are given. When you want to do force analysis for four-bar mechanism, the length of the links are given. Location of center of gravity with respect to point O2, point A, and point O4 are given. So RG2, RG3, RG4 are given. So we should know where are the center of gravity. And I assume that the location of center of gravity is at the midpoints of the links. If it's not, you just need to do some calculation to find RG2, RG3, and RG4. The mass of the moving links are given. Also, the mass momentum inertia about center of gravity of each link is given, RG2, RG3, and RG4. You have done the motion analysis. So theta 2, 3, 4, theta dot 2, theta dot 3, theta dot 4, and theta double dot 2, 3, and 4, they have been calculated. Since you know them, you can find the acceleration of center of gravity. I just erased that equation. You can find the acceleration of this point, and this point. Why do we need this? Because the right-hand side of equation has acceleration of center of gravity in x and y direction. So these are the steps that you need to do before you start the force analysis. So that these things should be calculated. Now I'm gonna look at each link individually and draw the free body diagram for link 2, 3, and 4. So let me talk about action and reaction force. At point O2, if this is link O2A, there are some force coming from ground applied to link 2. I labeled that with 1 to X and F1 to Y. The force coming from link 1 applied to link 2 in X direction. Force coming from link 1 applied to link 2 in Y direction. Suppose this is the action. The reaction would be the force applied from link 2 to the ground. So it's gonna be in the opposite direction, and the label is gonna change to 2, 1x. The force coming from link 2 applied to link 1, which is the ground, in x direction, and force coming from link 2 applied to link 1 in y direction. And what would be the relation between these two? F1 2y equals to negative F21y. And F1 2x equals to negative F1 F21x. This is action, this is the reaction. So if this is the force coming from the ground applied to link 2, at point A, there is some force coming from link 3 applied to link 2, 3 to x, and F3 to y. So I have point A, point O2. These are the only points that I can see that some other forces applied to this link. Point A, what would be the force coming from link 3 applied to link 2 in x direction? What would be the force coming from link 3 applied to link 2 in y direction? And the center of gravity is here, and we have one external torque coming from the motor. So for this link, if I write this equation, what would be the force in this x direction is going to be this plus this. F1 to x plus F3 to x equals to mass times acceleration of center of gravity for link 2 in x direction. ACG2 means acceleration of center of gravity for link 2. And x means in x direction. In y direction, I have these two forces. Last equation. What would be the torque applied to center of gravity? First, external torque. It has positive sign because we assume it's applied in counterclockwise direction. This force times this distance. I'm just writing the equation. You know how to derive that. F1 to x Rg2 sine of theta 2 minus F this force times this distance. It's making clockwise, so it's going to be negative. Negative F1 to y Rg2 cosine of theta 2. Minus this force times this distance is making clockwise, so it's making negative. So F32 times R2 minus Rg2 sine of theta 2 plus F32 R2 minus Rg2 cosine of theta 2. And this equals to right hand side, which is mass moment of inertia for link 2 times alpha 2. This is for link 2. For link 3, if this is point B, this is point A, this is point B. Force, point A. Force coming from link 2 applied to link 3. F23x, F23y. F23x, F23y. Link B, force coming from link 4 applied to link 3 in x direction. F43x, F43y. And center of gravity is right here for link 3. And this angle is theta 2. Sorry, theta 3. No external torque applied here. If there is any external force, you should add it to equation, but for this case, I don't have any external force. These are the only force that I can see applied to link 3. I'm rewriting these three equations one more time. First, F23x plus F43x equals to mass of link 3 times acceleration of center of gravity of link 3 in x direction, F23y plus F43y m3 acceleration of center of gravity of link 3 in y direction. And last equation, no external force, this force times this distance, making counterclockwise. So it's making positive rotation. F23 times Rg2 cosine of sine of theta 3 minus F23y Rg2 cosine of theta 3. This force times this distance, Rg2 times cosine of theta 3, it's making this distance. Just do the same things for these two forces. You're gonna get something like this, minus F 43x R3 minus Rg3 sine of theta 2 theta 3 plus F43 R2 minus Rg3 cosine of theta 3. Equation 1, equation 2, equation 3, 4, 5, 6. I left with one equation, one link. I'm done with the first two links with free body diagram. I just need to work on the last link, which is this guy. This is for link 4. At point 04, the force coming from link 4, link 1 applied to link 4, F1 4x, F1 4y. Let me write it down. This direction. And here at point B, force coming from link 3 applied to link 4 in x and y direction. And then write the equation F1 4x plus F3 4x equals to mass of link 4, acceleration of center of gravity for link 4 in x direction. F1 4y plus F3 4y, mass of link 4, acceleration of center of gravity of link 4 in y direction. And this is the torque. This force times this distance. This distance is Rg4 times sine of theta 4. This force is making clockwise, so it's going to be negative F 3, 4, x times R4 minus RG4 cosine sine of theta 4. And last term is positive F34y R4 minus RG4 cosine equals to I central gravity of length 4 times alpha 4. So I got 9 equations. I should solve this 9 equation for 9 unknowns. I can solve for 9 unknowns. The unknowns that I'm gonna get is gonna be f1 2x, f1 2y, input torque F3 2x, F3 2y, F4 3x, F4 3y, F1 4x, and F1 4y. Let's count the number of unknowns. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 unknowns. I can solve for 9 equations. You might say that we didn't count F3 4y. As you see, we don't have F3 4y. We have F4 3y. If you remember, we talked about action and reaction. F1 2 equals to negative F2 1. So if you have F3 4x, it's gonna be negative F4 3x. So some of the variables are dependent to others. Like F1 4, it's the variable, but F4 1. We don't have F4 1, never mind. We have F3 2, but in this equation we have F2 3. So you can plug in by negative. So any question on this? I'm gonna write the matrix form, just because you need that to work on the homeworks problem. Let me get it out. This guy. All right, I hope I captured it right here. We have 9 equations, so the coefficient matrix would be 9 by 9. We have 9 equations with 9 variables. The variables, I label them. I start writing them in this column, which is my column X, F1 to X, F1 to Y, TS, F3 to X, F3 to Y, F4 3X, F4 3Y, and the last two F1 4X, F1 4Y. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's start with the first equation. The first variable is f1 to x. What would be the coefficient of f1 to x? And the first equation is 1. f3 to x is unknown, but we don't have any f1 to y. So 1, the second one is going to be 0. There is no TS showed up there. 3 to x. 3 to x, I have 1, 3 to x. I put the coefficient of 3 to x. 1, 2, 3, 4. The rest would be 0. 5, 6, 7, 8, 9. Second equation. The coefficient of f1 to y is 1, but f1 to x is 0. So first one is 0. This is 1. No TS. And 3 to x is 0, but 3 to y is 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The coefficient of variable number 5 is 1. And there is no other variable here, so just put 0. Third equation, this one. The coefficient of TS is 1. What would be the coefficient of f1 to x? Rg2 sine of theta 2. Rg2 sine of theta 2. The coefficient of f1 to y is negative Rg2 cosine of theta 2. Negative Rg2 cosine of theta 2. Coefficient of TS is 1. 1, 2, 3, 4. 3 to x. 3 to x has this coefficient, negative R2 minus Rg2 sine of theta 2. And coefficient of 3 to y is positive and the rest would be 0. Equation number 1, 2, 3, 4. Equation number 4. It's f23. This one, this one, this one would be 0, so the first three would be 0, 0, 0, 0. 1, 2, 3. I have 2, 3. The variable is 3, 2. So the coefficient of 3, 2 is going to be negative f32. So I put negative 1. The coefficient of 3 to y is 0. One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 4, 3. 4, 3. I have 4, 3. Here I have 4, 3 with the coefficient of 1. The rest would be 0. This equation equation number 5. Equation number 5. 1, 2, 3, 4, 5. 0, 0, 0. F23. F23 x or 23 y. Yes, 0. So it's gonna be y. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 2, 3 is gonna be negative f 3, 2. This one is gonna be 0. This one is gonna be 1, 0, 0. Number 6. I'm just writing the number 6. 1, 2, 3, 4, 5. Number 6. 0, 0, 0. 3, 0. And then negative Rg3 sine of theta 3. Then Rg3 cosine of theta 3. then negative R3 minus RG3 sine theta 3 R3 minus RG3 cosine of theta 3 and 1 2 2 0. Write the equation for 7, 8, and 9. You will end up to this system equation. I wrote for the first 6 lines, 7 and 8 and 9 would be the same. So in this matrix, this column and this column are known, or you can calculate. You solve for these values. So I need to define 2 terms. One is shaking force. The other one is shaking moment. Shaking force would be the force applied to the ground. So what would be the force that this mechanism is going to apply to the ground? We have 2 forces applied to the ground from this mechanism. One is from link 2 applied to the ground. The other one, ground is 1. Plus, because we have two joints connecting to the ground, the other force would be force coming from link 4 applied to the ground. So the summation of these two is called shaking force. How can you add them up? You can add F21x plus F41x for x component of shaking force, Fs in x, and for the y, F21y plus F41y Fsy. So shaking force in x direction, shaking force in y direction. Shaking moment would be what would be the torque coming from the ground or the motor that we labeled as a Ts. So after you find this value, you can find shaking force and the shaking ground. Shaking moment, sorry. For the homework, there is only one problem, but it's a long one. It's not too bad. It's a problem that you already solved on homework 8. The length of the links are the same. For the open mode, you did the acceleration analysis. Now I'm asking you to do force analysis for angle of 0 to 360 with a step length of 5 degrees. Plot shaking force versus input angle, shaking force versus theta. What else? Also find the input torque required to drive the mechanism for all input angles. So what would be the Ts as an angle of, as a function of theta, and find me at which angle we are going to have the maximum torque needed to drive this mechanism. These are the information that you are given. Mass link is 2. The link of 2 has the weight of 0.6, 2.1, and 2.7, and mass moment of inertia is given. So it takes time to write the code, so don't leave it by the last day.
Got it. So since this is kind of based on our code from the last homework, are you going to post like a solution to that? Because if our code for the last homework's wrong, that means
It's just gonna waterfall.
I can post the code for the acceleration. Is that right? It has velocity and
Yeah,
with
displacement.
iteration.
If that's wrong, everything on
Yes.
this homework's going to be wrong.
Yeah.
so we have zero chance.
Okay, sure.
And this won't be graded until that's due, so.
That's true. So what you can do, you can check your code with mine. If it's the same, just stick to your code. If it's wrong, you can use my code or revise your code until you get the
Thank you.
correct answer. Yeah.
Okay.
All right.
No, I-